Tonight, if you look up, there are roughly 10,000 stars visible to your naked eye. Now imagine every single one of them dying at the same moment. Not fading, not blinking out slowly, just gone. Every star in the Milky Way, every star in Andromeda, every star in every galaxy you have ever seen in a photograph. All of them, right now. What happens next is not what you think. You would not die instantly. That is the first surprise. Light from the sun takes 8 minutes and 20 seconds to reach Earth. That means for 8 minutes you would not even know. You would keep scrolling on your phone. You would keep sipping your coffee. The sky would still be blue because sunlight already hit the atmosphere before the sun vanished. You would have 8 minutes of total normalcy, while the universe around you had already ended. Then the light runs out. The sky goes dark, not nighttime dark, not cloudy day dark, true dark. The kind of dark your eyes have never actually experienced because the sun has always been there, even when it was on the other side of the planet. Without the sun, the atmosphere stops scattering blue light. There is nothing to scatter. The sky turns black in every direction, day and night, and it stays that way forever. But stars are not just light. Stars are heat. They are gravity. They are the engines that make almost everything in the universe exist. So what happens when every engine shuts off at once? The first thing you would notice, after the darkness, is the cold. Earth radiates heat into space constantly, but the sun replaces it constantly too. That balance disappears the moment the sun dies. Within 1 week, the average surface temperature on Earth drops to 0 degrees Fahrenheit. That is negative 18 Celsius. Oceans start freezing from the top down. Within 1 year, the surface temperature falls to negative 100 degrees Fahrenheit. The atmosphere itself begins to condense. Nitrogen and oxygen start raining out of the sky as liquid. Within a few years, Earth is a frozen, airless rock drifting through absolute darkness. No wind, no weather, no sound except whatever is happening inside the last heated shelters humanity managed to build. But you would not make it that far, because something else is happening first. Photosynthesis stops the moment sunlight disappears. Every plant on Earth, every blade of grass, every phytoplankton in the ocean, every tree in every forest, they all stop producing oxygen. Not immediately. They have stored energy. They can survive in the dark for a little while, but within weeks the food chain collapses from the bottom up. Plants die, herbivores starve, carnivores follow. The ocean goes silent. Phytoplankton, which produce roughly 50 to 80% of Earth's oxygen according to the National Oceanic and Atmospheric Administration, shut down completely. The air you breathe starts to change. Now zoom out, because this is not just about Earth. Every star in the universe is gone. That means every planet orbiting every star in every galaxy has just experienced the same catastrophe. Every potential world where life might have been forming, every ocean under every distant sun, every possible civilization looking up at their own sky in confusion, they are all freezing too. The universe just went dark in every direction, in every galaxy, around every forgotten corner of existence. But what made the stars go out? That question matters because it determines what happens to the matter those stars were made of. Stars are not just giant light bulbs. They are balancing acts. A star exists because two forces are fighting each other, gravity pulling inward and nuclear fusion pushing outward. Fusion is the process where a star's core squeezes hydrogen atoms so tightly that they merge into helium, releasing enormous amounts of energy. That energy is what makes a star shine. When fusion stops, gravity wins. The core collapses. If every star in the universe suddenly lost its fusion process, the result would be universal collapse. Stars smaller than our sun would shrink into white dwarfs, dense glowing embers the size of Earth but with the mass of a star. Stars larger than the sun would explode as supernovae, scattering their heavier elements across space in expanding shockwaves. The largest stars would collapse directly into black holes. So the universe would not just go dark, it would briefly go violent. Supernovae would erupt across every galaxy simultaneously. The Milky Way alone contains an estimated 100 to 400 billion stars. Not all of them would explode, only the massive ones. But that is still millions of simultaneous stellar explosions, each one brighter than an entire galaxy for a brief window of time. The sky would go dark, then briefly flash with millions of dying suns, then go dark again permanently. In 1987, astronomers observed a supernova called SN 1987A in the Large Magellanic Cloud, a small galaxy orbiting the Milky Way. It was the closest supernova observed in modern history, roughly 160,000 light-years away. For a few weeks, It was visible to the naked eye from the southern hemisphere. Now imagine millions of those happening at once across every galaxy in the observable universe. The brief flash would be the most spectacular light show in cosmic history, and then it would end, and the darkness that followed would last forever. Because here is what comes next. Without new stars forming and without fusion energy pouring into space, the universe enters what physicists call the heat-death scenario. It is not hot. The name is misleading. Heat death means that all energy is spread so evenly across the universe that nothing interesting can happen anymore. No temperature differences, no chemical reactions, no work can be performed. The universe reaches maximum entropy, maximum disorder, maximum emptiness. Freeman Dyson, the theoretical physicist who spent decades studying the long-term fate of the universe, published a landmark paper in 1979 called Time Without End. Can life survive forever? He argued that intelligent life could potentially survive indefinitely by slowing down its metabolism as the universe cooled, hibernating between moments of activity across increasingly long stretches of time. But even Dyson admitted that, without stars, the energy sources available to any surviving civilization would dwindle to almost nothing over trillions of years. You cannot hibernate your way through infinite darkness if there is no energy left to wake up to. Roger Penrose, the Nobel Prize-winning physicist from the University of Oxford, developed a theory called conformal cyclic cosmology. He proposed that the universe goes through infinite cycles, each one beginning with a Big Bang and ending in maximum expansion and heat death, which then becomes the seed of a new Big Bang. In his model, the death of every star is not the end. It is a transition. The universe does not stop. It resets. But the timescale involved is so incomprehensibly vast that no living thing could witness it, not even close. The European Space Agency's Planck satellite mapped the cosmic microwave background radiation, the leftover light from the Big Bang itself, between 2009 and 2013. That radiation is the oldest light in the universe, released roughly 380,000 years after the Big Bang. It is everywhere. It fills all of space, and even that would not save you. The cosmic microwave background is already cooling, already fading. Without stars to replace it, the last whisper of the universe's origin would eventually redshift into nothing. The universe would become a void of black holes, dead planets, drifting dust, and silence. Here is the part that should unsettle you the most. This is not entirely hypothetical. Every star in the universe will eventually die, not all at once. But one by one, over trillions of years, every star will burn through its fuel and go dark. The last stars to die will be red dwarfs, the smallest and longest-lived stars in the universe. They burn their hydrogen so slowly that some of them will shine for over 10 trillion years. That is roughly 1,000 times longer than the current age of the universe. But even they will die. And after they do, the scenario you just imagined becomes reality. Not suddenly, not dramatically, but inevitably. The universe is currently 13.8 billion years old. The stelliferous era, the age of stars, will last maybe 100 trillion years. After that, nothing shines. The universe enters its dark era. Black holes slowly evaporate through a process called Hawking radiation, predicted by Stephen Hawking in 1974. That takes roughly 10 to the power of 67 years for a star-sized black hole. For the supermassive black holes at the centers of galaxies, it takes 10 to the power of 100 years. After even the last black hole evaporates, the universe is just a diffuse soup of particles, photons, and silence, stretching infinitely in every direction. You live in the one tiny window of cosmic time where stars exist, where light fills the sky, where planets orbit warm suns and life can form and look up and wonder. That window is real. It is happening right now, and it will not last forever. Nothing will. The stars above you tonight are not permanent fixtures. They are temporary fires, and every single one of them is already dying. You just happen to be alive while they are still burning. So the next time you step outside and look up at the sky, remember this. The darkness between those stars is not empty space waiting to be filled. It is the future. It is what the entire universe will become. The stars are not lighting up the darkness. They are delaying it. And you right now, right here, standing on this rock, looking up with your imperfect human eyes, you are living inside the delay. That is not sad. That is not terrifying. That is the most extraordinary thing that could ever be true. You exist during the light.